The Tunguska event was a large explosion that occurred near the Podkamenaya Tunguska River in Yeniseisk Governorate, now Krasnoyarsk Krai, Russia, on the morning of 30 June 1908 NS. The explosion over the sparsely populated eastern Siberian taiga flattened 2,000 square kilometers (770 square miles) of forest, yet caused no known human casualties. The explosion is generally attributed to the airburst of a meteor. It is classified as an impact event, even though no impact crater has been found. The object is thought to have disintegrated at an altitude of 5 to 10 kilometers (3 to 6 miles) rather than to have hit the surface of the Earth. The Tunguska event is the largest impact event on Earth in recorded history. Studies have yielded different estimates of the meteoroid's size, on the order of 60 to 190 meters (200 to 620 feet), depending on whether the body was a comet or a denser asteroid. Since the 1908 event, there have been an estimated 1,000 scholarly papers, most in Russian, published on the Tunguska explosion. In 2013, a team of researchers published analysis results of micro-samples from a peat bog near the center of the affected area showing fragments that may be of meteoritic origin. Early estimates of the energy of the airburst range from 10 to 15 megatons of TNT, 42 to 63 petajoules, to 30 megatons of TNT, 130 petajoules, depending on the exact height of burst estimated when the scaling laws from the effects of nuclear weapons are employed. However, modern supercomputer calculations that include the effect of the object's momentum find that more of the energy was focused downward than would be the case from a nuclear explosion and estimate that the airburst had an energy range from 3 to 5 megatons of TNT, 13 to 21 petajoules. The 15 megaton (MT) estimate represents an energy about 1,000 times greater than that of the atomic bomb dropped on Hiroshima, Japan. Roughly equal to that of the United States Castle Bravo, 15.2 MT, ground-based thermonuclear detonation on 1 March 1954, and about one-third that of the Soviet Union's Tsar Bomba explosion on 30 October 1961, which, at 50 Mount, is the largest nuclear weapon ever detonated. It is estimated that the Tunguska explosion knocked down some 80 million trees over an area of 2,150 square kilometers, 830 square miles, and that the shock wave from the blast would have measured 5.0 on the Richter magnitude scale. An explosion of this magnitude would be capable of destroying a large metropolitan area, but, due to the remoteness of the location, no human fatalities were officially documented. Several reports have indicated that 2 people may have died in the event, but those deaths remain unofficial. The Tunguska event has helped to spark discussion of asteroid impact avoidance. Topic. Description. On 30 June 1908, at around 7:17 local time, Evenki natives and Russian settlers in the hills northwest of Lake Baikal observed a column of bluish light, nearly as bright as the sun, moving across the sky. About 10 minutes later, there was a flash and a sound similar to artillery fire. Eyewitnesses closer to the explosion reported that the source of the sound moved from the east to the north of them. The sounds were accompanied by a shock wave that knocked people off their feet and broke windows hundreds of kilometers away. The majority of witnesses reported only the sounds and tremors, and did not report seeing the explosion. Eyewitness accounts vary regarding the sequence and duration of the events. The explosion registered at seismic stations across Eurasia, and air waves from the blast were detected in Germany, Denmark, Croatia, the UK, and as far away as Batavia and Washington, D.C. It is estimated that, in some places, the resulting shock wave was equivalent to an earthquake, measuring 5.0 on the Richter magnitude scale. Over the next few days night skies in Asia and Europe were aglow, with contemporaneous reports of photographs being successfully taken at midnight in both Sweden and Scotland. It has been theorized that this effect was due to light passing through high-altitude ice particles that had formed at extremely low temperatures, a phenomenon that many years later would be produced by space shuttles. In the United States, a Smithsonian Astrophysical Observatory program at the Mount Wilson Observatory observed a months-long decrease in atmospheric transparency consistent with an increase in suspended dust particles.
Selected eyewitness reports. Testimony of S. Semyonov, as recorded by Leonid Kulik's expedition in 1930. At breakfast time I was sitting by the house at Vanavara trading post 65 kilometers, 40 miles south of the explosion, facing north. I suddenly saw that directly to the north, over Onkaul's Tunguska road, the sky split in two and fire appeared high and wide over the forest as Semyonov showed, about 50 degrees up. Expedition note. The split in the sky grew larger, and the entire northern side was covered with fire. At that moment I became so hot that I couldn't bear it, as if my shirt was on fire. From the northern side, where the fire was, came strong heat. I wanted to tear off my shirt and throw it down, but then the sky shut closed, and a strong thump sounded, and I was thrown a few meters. I lost my senses for a moment, but then my wife ran out and led me to the house. After that such noise came, as if rocks were falling or cannons were firing, the earth shook, and when I was on the ground, I pressed my head down, fearing rocks would smash it. When the sky opened up, hot wind raced between the houses, like from cannons, which left traces in the ground like pathways, and it damaged some crops. Later we saw that many windows were shattered, and in the barn, a part of the iron lock snapped. Testimony of Chuchin of Shanyazhir tribe, as recorded by I. M. Suslov in 1926. We had a hut by the river with my brother Chekarin. We were sleeping. Suddenly we both woke up at the same time. Somebody shoved us. We heard whistling and felt strong wind. Chekarin said, "Can you hear all those birds flying overhead?" We were both in the hut, couldn't see what was going on outside. Suddenly, I got shoved again, this time so hard I fell into the fire. I got scared. Chekarin got scared too. We started crying out for father, mother, brother, but no one answered. There was noise beyond the hut, we could hear trees falling down. Chekarin and I got out of our sleeping bags and wanted to run out, but then the thunder struck. This was the first thunder. The earth began to move and rock, the wind hit our hut and knocked it over. My body was pushed down by sticks, but my head was in the clear. Then I saw a wonder, trees were falling, the branches were on fire, it became mighty bright. How can I say this, as if there was a second sun, my eyes were hurting, I even closed them. It was like what the Russians call lightning. And immediately there was a loud thunderclap. This was the second thunder. The morning was sunny, there were no clouds, our sun was shining brightly as usual, and suddenly there came a second one. Chekarin and I had some difficulty getting out from under the remains of our hut. Then we saw that above, but in a different place, there was another flash, and loud thunder came. This was the third thunder strike. Wind came again, knocked us off our feet, struck the fallen trees. We looked at the fallen trees, watched the tree tops get snapped off, watched the fires. Suddenly Chekarin yelled, "Look up!" and pointed with his hand. I looked there and saw another flash, and it made another thunder. But the noise was less than before. This was the fourth strike, like normal thunder. Now I remember well there was also one more thunderstrike, but it was small, and somewhere far away, where the sun goes to sleep. Sibir newspaper, 2 July 1908. On the morning of 17 June, around 9 o'clock, we observed an unusual natural occurrence. In the North Karelinsky village 200 verst 213 kilometers 132 miles north of Kerensk, the peasants saw to the northwest, rather high above the horizon, some strangely bright, impossible to look at, bluish-white heavenly body, which for 10 minutes moved downwards. The body appeared as a pipe,
i.e., a cylinder. The sky was cloudless, only a small dark cloud was observed in the general direction of the bright body. It was hot and dry. As the body neared the ground forest, the bright body seemed to smudge, and then turned into a giant billow of black smoke, and a loud knocking, not thunder, was heard as if large stones were falling, or artillery was fired. All buildings shook. At the same time the cloud began emitting flames of uncertain shapes. All villagers were stricken with panic and took to the streets. Women cried, thinking it was the end of the world. The author of these lines was meantime in the forest about 6 versts (6.4 kilometers) north of Kerensk and heard to the northeast some kind of artillery barrage, that repeated in intervals of 15 minutes at least 10 times. In Kerensk, in a few buildings in the walls facing northeast window glass shook. Siberian Life newspaper, 27 July 1908. When the meteorite fell, strong tremors in the ground were observed, and near the Lovett village of the Konsk Uzd 2 strong explosions were heard, as if from large-caliber artillery. Krasnoyarets newspaper, 13 July 1908. Kezhemsko village. On the 17th an unusual atmospheric event was observed. At 7:43 the noise akin to a strong wind was heard. Immediately afterward a horrific thump sounded, followed by an earthquake that literally shook the buildings as if they were hit by a large log or a heavy rock. The first thump was followed by a second, and then a third. Then the interval between the first and the third thumps was accompanied by an unusual underground rattle, similar to a railway upon which dozens of trains are traveling at the same time. Afterward, for 5 to 6 minutes an exact likeness of artillery fire was heard, 50 to 60 salvos in short, equal intervals, which got progressively weaker. After 1.5 to 2 minutes after one of the barrages, 6 more thumps were heard, like cannon firing, but individual, loud and accompanied by tremors. The sky, at the first sight, appeared to be clear. There was no wind and no clouds. Upon closer inspection to the north, i.e. where most of the thumps were heard, a kind of an ashen cloud was seen near the horizon, which kept getting smaller and more transparent and possibly by around 2 to 3 p.m. completely disappeared.
Investigations. It was more than a decade after the event before any scientific analysis of the region took place. In 1921, the Russian mineralogist Leonid Kulik led a team to the Podkamenaya Tunguska River basin to conduct a survey for the Soviet Academy of Sciences. Although they never visited the central blast area, the many local accounts of the event led Kulik to believe that the explosion had been caused by a giant meteorite impact. Upon returning, he eventually persuaded the Soviet government to fund an expedition to the suspected impact zone, based on the prospect of salvaging meteoric iron. Kulik was finally able to lead a scientific expedition to the Tunguska blast site in 1927. He hired local Evenki hunters to guide them to the center of the blast area, where they expected to find an impact crater. To their surprise, there was no crater to be found at ground zero. Instead they found a zone, roughly 8 kilometers (5.0 miles) across, where the trees were scorched and devoid of branches, but still standing upright. The trees farther away had been partly scorched and knocked down in a direction away from the center. Much later, in the 1960s, it was established that the zone of leveled forest occupied an area of 2,150 square kilometers (830 square miles), its shape resembling a gigantic spread-eagled butterfly with a wingspan of 70 kilometers (43 miles) and a body length of 55 kilometers (34 miles). Upon closer examination, Kulik located holes that he erroneously concluded were meteorite holes. He did not have the means at that time to excavate the holes. During the next 10 years there were 3 more expeditions to the area. Kulik found several dozens of little pothole bogs, each some 10 to 50 meters (33 to 164 feet) in diameter, that he thought might be meteoric craters. After a laborious exercise in draining one of these bogs, the so-called Sislov's crater, 32 meters (105 feet) in diameter, he found an old stump on the bottom, ruling out the possibility that it was a meteoric crater. In 1938, Kulik arranged for an aerial photographic survey of the area covering the central part of the leveled forest, 250 square kilometers (97 square miles). The negatives of these aerial photographs, 1,500 negatives, each 18 by 18 centimeters (7.1 by 7.1 inches), were burned in 1975 by order of Yevgeny Krinov, then chairman of the Committee on Meteorites of the USSR Academy of Sciences, as part of an initiative to dispose of hazardous nitrate film. Positive prints were preserved for further study in the Russian city of Tomsk. Expeditions sent to the area in the 1950s and 1960s found microscopic silicate and magnetite spheres in siftings of the soil. Similar spheres were predicted to exist in the felled trees, although they could not be detected by contemporary means. Later expeditions did identify such spheres in the resin of the trees. Chemical analysis showed that the spheres contained high proportions of nickel relative to iron, which is also found in meteorites, leading to the conclusion they were of extraterrestrial origin. The concentration of the spheres in different regions of the soil was also found to be consistent with the expected distribution of debris from a meteoroid air burst. Later studies of the spheres found unusual ratios of numerous other metals relative to the surrounding environment, which was taken as further evidence of their extraterrestrial origin. Chemical analysis of peat bogs from the area also revealed numerous anomalies considered consistent with an impact event. The isotopic signatures of stable carbon, hydrogen, and nitrogen isotopes at the layer of the bogs corresponding to 1908 were found to be inconsistent with the isotopic ratios measured in the adjacent layers, and this abnormality was not found in bogs located outside the area. The region of the bogs showing these anomalous signatures also contains an unusually high proportion of iridium, similar to the iridium layer found in the Cretaceous-Paleogene boundary. These unusual proportions are believed to result from debris from the falling body that deposited in the bogs. The nitrogen is believed to have been deposited as acid rain, a suspected fallout from the explosion. Researcher John Anfinogenov has suggested that a boulder found at the event site, known as John's Stone, is a remnant of the meteorite. Topic: Earth impactor model. Topic: Asteroid air burst.
The leading scientific explanation for the explosion is the airburst of an asteroid 6 to 10 kilometers (4 to 6 miles) above Earth's surface. Meteoroids enter Earth's atmosphere from outer space every day, traveling at a speed of at least 11 kilometers per second, 7 miles per second. The heat generated by compression of air in front of the body, ram pressure, as it travels through the atmosphere is immense, and most meteoroids burn up or explode before they reach the ground. Since the second half of the 20th century, close monitoring of Earth's atmosphere through infrasound and satellite observation has shown that asteroid airbursts with energies comparable to those of nuclear weapons routinely occur, although Tunguska-sized 5 to 15 megaton events are much rarer. Eugene Shoemaker estimated that 20 kiloton events occur annually and that Tunguska-sized events occur about once every 300 years. More recent estimates place Tunguska-sized events at about once every 1,000 years, with 5 kiloton airbursts averaging about once per year. Most of these airbursts are thought to be caused by asteroid impactors as opposed to mechanically weaker cometary materials based on their typical penetration depths into the Earth's atmosphere. The largest asteroid airburst to be observed with modern instrumentation was the 500-kiloton Chelyabinsk meteor of 2013, which shattered windows and produced meteorites.
Blast patterns. The explosion's effect on the trees near the hypocenter of the explosion was replicated during atmospheric nuclear tests in the 1950s and 1960s, and was similar to the effects of the conventional Operation Blowdown. These effects are caused by the blast wave produced by large airburst explosions. The trees directly below the explosion are stripped as the blast wave moves vertically downward, while trees farther away are knocked over because the blast wave is traveling closer to horizontal when it reaches them. Soviet experiments performed in the mid-1960s, with model forests made of matches on wire stakes and small explosive charges slid downward on wires, produced butterfly-shaped blast patterns strikingly similar to the pattern found at the Tunguska site. The experiments suggested that the object had approached at an angle of roughly 30 degrees from the ground and 115 degrees from north and had exploded in midair. Asteroid or comet. In 1930, the British astronomer F. J. W. Whipple suggested that the Tunguska body was a small comet. A comet is composed of dust and volatiles, such as water ice and frozen gases, and could have been completely vaporized by the impact with Earth's atmosphere, leaving no obvious traces. The comet hypothesis was further supported by the glowing skies or skyglows, or bright nights, observed across Europe for several evenings after the impact, possibly explained by dust and ice that had been dispersed from the comet's tail across the upper atmosphere. The cometary hypothesis gained a general acceptance amongst Soviet Tunguska investigators by the 1960s. In 1978, Slovak astronomer Lubor Křeček suggested that the body was a fragment of comet Encke. This is a periodic comet with an extremely short period of 3 years that stays entirely within the orbit of Jupiter. It is also responsible for the Beta Taurids, an annual meteor shower with a maximum activity around 28 to 29 June. The Tunguska event coincided with the peak activity of that shower, and the approximate trajectory of the Tunguska object is consistent with what would be expected from a fragment of comet Encke. It is now known that bodies of this kind explode at frequent intervals tens to hundreds of kilometers above the ground. Military satellites have been observing these explosions for decades. During 2019, astronomers hope to search for hypothesized asteroids approximately 100 meters in diameter from the Taurid swarm between July 5 to 11, and July 21 to August 10. In 1983, astronomer Zdeněk Šekinina published a paper criticizing the comet hypothesis. He pointed out that a body composed of cometary material, traveling through the atmosphere along such a shallow trajectory, ought to have disintegrated, whereas the Tunguska body apparently remained intact into the lower atmosphere. Šekinina argued that the evidence pointed to a dense, rocky object, probably of asteroidal origin. This hypothesis was further boosted in 2001, when Farinella, Fascini, et al. Released a study calculating the probabilities based on orbital modeling extracted from the atmospheric trajectories of the Tunguska object. They concluded with a probability of 83% that the object moved on an asteroidal path originating from the asteroid belt, rather than on a cometary one, probability of 17%. Proponents of the comet hypothesis have suggested that the object was an extinct comet with a stony mantle that allowed it to penetrate the atmosphere. The chief difficulty in the asteroid hypothesis is that a stony object should have produced a large crater where it struck the ground, but no such crater has been found. It has been hypothesized that the passage of the asteroid through the atmosphere caused pressures and temperatures to build up to a point where the asteroid abruptly disintegrated in a huge explosion. The destruction would have to have been so complete that no remnants of substantial size survived, and the material scattered into the upper atmosphere during the explosion would have caused the skyglows. Models published in 1993 suggested that the stony body would have been about 60 meters (200 feet) across, with physical properties somewhere between an ordinary chondrite and a carbonaceous chondrite. Typical carbonaceous chondrite substance tends to be dissolved with water rather quickly unless it is frozen. Christopher Chiba and others have proposed a process whereby a stony meteorite could have exhibited the behavior of the Tunguska impactor. Their models show that when the forces opposing a body's descent become greater than the cohesive force holding it together, it blows apart, releasing nearly all its energy at once. The result is no crater, with damage distributed over a fairly wide radius, and all of the damage resulting from the thermal energy released in the blast. Three-dimensional numerical modeling of the Tunguska impact done by Utuzhnikov and Rudenko in 2008 supports the comet hypothesis. According to their results, the comet matter dispersed in the atmosphere, while the destruction of the forest was caused by the shock wave. During the 1990s, Italian researchers, coordinated by the physicist Giuseppe Longo from University of Bologna, extracted resin from the core of the trees in the area of impact to examine trapped particles that were present during the 1908 event. They found high levels of material commonly found in rocky asteroids and rarely found in comets. Kelly et al. 2009 contend that the impact was caused by a comet because of the sightings of noctilucent clouds following the impact, a phenomenon caused by massive amounts of water vapor in the upper atmosphere. They compared the noctilucent cloud phenomenon to the exhaust plume from NASA's Endeavour Space Shuttle. In 2013, analysis of fragments from the Tunguska site by a joint US-European team was consistent with an iron meteorite. Topic: Lake Checo. In June 2007, scientists from the University of Bologna identified a lake in the Tunguska region as a possible impact crater from the event. They do not dispute that the Tunguska body exploded in midair but believe that a 10-meter fragment survived the explosion and struck the ground. Lake Checo is a small, bowl-shaped lake approximately 8 kilometers (5.0 miles) north-northwest of the hypocenter. The hypothesis has been disputed by other impact crater specialists. A 1961 investigation had dismissed a modern origin of Lake Checo, saying that the presence of meters-thick silt deposits at the lake's bed suggests an age of at least 5,000 years, but more recent research suggests that only a meter or so of the sediment layer on the lake bed is normal lacustrine sedimentation, a depth consistent with an age of about 100 years. Acoustic echo soundings of the lake floor provide support for the hypothesis that the lake was formed by the Tunguska event. The soundings revealed a conical shape for the lake bed, which is consistent with an impact crater. Magnetic readings indicate a possible meter-sized chunk of rock below the lake's deepest point that may be a fragment of the colliding body. Finally, the lake's long axis points to the hypocenter of the Tunguska explosion, about 7.0 kilometers (4.3 miles) away. Work is still being done at Lake Checo to determine its origins. The main points of the study are that Checo, a small lake located in Siberia close to the hypocenter of the 1908 Tunguska explosion, might fill a crater left by the impact of a fragment of a cosmic body. Sediment cores from the lake's bottom were studied to support or reject this hypothesis. A 175 cm long 69 in core, collected near the center of the lake, consists of an upper sea, 1 meter thick 39 in sequence of lacustrine deposits overlaying coarser chaotic material. 210 petabits and 137 Cs indicate that the transition from lower to upper sequence occurred close to the time of the Tunguska event. Pollen analysis reveals that remains of aquatic plants are abundant in the top post-1908 sequence but are absent in the lower pre-1908 portion of the core. These results, including organic C, N and delta-13C data, suggest that Lake Checo formed at the time of the Tunguska event. In 2017, however, new research by Russian scientists points to a rejection of the theory. They used soil research to prove that the lake is 280 years old or even much older, in any case clearly older than the Tunguska events. Geophysical hypotheses. The scientific consensus is that the explosion was caused by the impact of a small asteroid, however, there are some dissenters. Astrophysicist Wolfgang Kundt has proposed that the Tunguska event was caused by the release and subsequent explosion of 10 million tons of natural gas from within Earth's crust. The basic idea is that natural gas leaked out of the crust and then rose to its equal density height in the atmosphere. From there, it drifted downwind, in a sort of wick, which eventually found an ignition source such as lightning. Once the gas was ignited, the fire streaked along the wick, and then down to the source of the leak in the ground, whereupon there was the explosion. The similar Vernschott hypothesis has also been proposed as a possible cause of the Tunguska event. Other research has supported a geophysical mechanism for the event. Similar events. The Tunguska event is not the only example of a great unobserved explosion event. For example, the 1930 Caruca River event in Brazil was an explosion of a superbolide that left no clear evidence of an impact crater. Modern developments in infrasound detection by the Comprehensive Nuclear Test Ban Treaty Organization and infrared DSP satellite technology have reduced the likelihood of undetected airbursts. A smaller air burst occurred over a populated area in Russia on 15 February 2013, at Chelyabinsk in the Ural district of Russia. The exploding meteoroid was an asteroid that measured about 17 to 20 meters across, with an estimated initial mass of 11,000 tons, and inflicted over 1,200 injuries, mainly from broken glass falling from windows shattered by its shock wave. In popular culture. See also: Chelyabinsk meteor, 2013 meteor airburst over western Russia. Potomsky crater, about 830 kilometers (515 miles) to the east-southeast. Sikhote-Alin meteorite, 1947 impact. Tunguska Nature Reserve, protected area covering a portion of the site, ongoing scientific study of forest recovery. Tal el Hammam, a Middle Bronze Age site reportedly destroyed by an airburst.